Okay, hello everyone. Thanks for coming. Hopefully you're enjoying the event so far. Hopefully my mobile doesn't go down. Yeah, it's going down. We'll move it to here. So, how are you doing so far? How is the event? Are you enjoying it so far? Nice, 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 nice. I like it. Actually, this time I didn't do that much like talks. I didn't see that much talks, so I don't know how is it going. Okay, so the topic of today is actually what you are currently seeing, multi-ready Flutter. And the idea is that we are going to talk about UWB. We are going to see what the hell is UWB, BLE and beyond, because also we have another radio technologies. So first of all, who am I? Why I'm here? So my name is Ahmed Hamdan. Actually, it's in Arabic, Ahmed Hamdan. But sometimes people call me Ahmed. Whenever you are in Germany, for example, they call you Ahmed, and Spain is a different name. So you can call me whatever you want. It's fine. Okay. I'm Flutter Platforms Lead at Mavenwolf. Actually, I have some amazing colleagues here also from Mavenwolf. I was the RCP dev lead on my BMW, the my BMW app. And from this stage, actually, I would also like to thank my BMW, since they allowed me to talk about many things that we don't talk about. I'm also the community lead of the Flutter Valencia. Actually, I have here my co-organizer, Luis. Thank you for coming. And I'm a public speaker. Actually, people that think that normally I only give like talks about Flutter and technology, but actually I did give more talks about other things, external things, more than even Flutter. So, what is Mavenwolf? Short introduction. I'm not doing here spam. Basically, Mavenwolf is an old company. It's actually a company based in Germany. It's actually founded in Munich. We actually have offices kind of like in all places in Germany. We have 11 locations. One of the offices in Valencia, where I'm currently in. There is also an office in Tunisia. And actually, it's not a new company. It's quite an old company. It was founded in 1989, and we are nearly like 1,000 employees. Enough spam. Let's start with the talk. So, UWB. First of all, who heard before about UWB? Nice, nice, nice. This is good. So for the people that didn't hear about UWB, let's do a short introduction. The talk is not about UWB. It's about multi-radio and how to actually handle multi-radio technologies, and how we also had some challenges on some big apps like my BMW, and how we managed to fix them. But of course, since many people are not familiar with UWB, we're going to at least have some definition of UWB. Why is it cool to have UWB, and where is it used? So normally I don't have on the slides that much like definition. Don't worry, this is the only slide that there is a definition. But yeah, I would like to have at least some definition for ultra-wideband. Basically, UWB is the short for ultra-wideband, and it's basically a short-range wireless communication protocol that uses radio waves, basically just like Bluetooth or Wi-Fi. But it's used more for precise ranging, and this is actually also one of the usages that we were doing on BMW side. The good thing and the cool thing about UWB is actually how precise it can be. It can be gone to the centimeter levels. So in Bluetooth, you need it more like a range about meters sometimes, even more. But in the cool part about ultra-wideband and the way that it works, that we are going to explain it, is that you can get, based on this calculation, you all studied physics, so you know, the distance that it measures based on the time of flight. So this is why it's more accurate, okay? Also, something cool in UWB, but this is not in all devices. We are going to talk about it more next. Some of the devices, some of the antennas in some of the mobiles, for example, in the U1 that you have the iPhones, support also the angle of arrival. So basically, you can know if the other device that you're connected with, is it above, is it down, what's the angle of the arrival, okay? BMW and UWB, because we've seen here some, I jumped it actually. There is some examples that we actually have in our day-to-day life, actually, of UWB. For example, the Find My Device one, that you actually can find your AirTag, or you can find your AirPods, or anything is based also on UWB technology. This is why you actually can see the angle, and actually can see the precise location where it's located. Something cool that is not that much talk about, I'm not sure why it doesn't maybe marketing work that much, is something that Xiaomi presented also on smart homes, actually, how they use the UWB technology. They have something called a trigger to action, where basically you can point, for example, to this, how is it called, pointer? Or to this projector, and then you can trigger an action just pointing it, because we know the direction thanks to UWB. And you can suddenly point to the TV and you can trigger it. And this is actually quite cool. Another application is how we use it in BMW. And basically, BMW needed this for digital keys, since now we have the ability that you can actually have your key, the normal key that you normally use, you can have it on your mobiles. And actually, all the car companies are trying to focus to go a little bit on the mobile and not depend that much on the key itself, no? And why they are using UWB? Basically because, yeah, there is precise location, and UWB tracks the exact position of your phone as the digital key, and there is like seamless access, strong security. Actually, I think I just noticed something, and you will need to excuse me, because I think I have the old slides here. Technical issues, sorry. Yeah, we talk about why UWB and how we use it also on BMW. How UWB works, basically it's like very short signals that we have. This is like pulse signals, we call it sometimes pulse signals. And basically it has this wide band that is this is why actually it's called UWB, ultra wideband, that is very different from how Bluetooth works and can send bunch of data on this wideband, okay? And measures the travel time to calculate the distance and the angles, as we talked, if the device actually provides that. Some requirements, and this is also important to know, is that not all the devices, and this is maybe why UWB is not used that much on real case scenarios or on everyday developers day, or even like indies devs, because you need to have this UWB antenna, which is quite expensive, and it's only on some flagship phones, basically. And in case of Apple, it's only on iPhone 11 and newer apps. And in case of Apple Watch series, or you also have it actually in the Apple Watch, you have also UWB with the U1 chip. They call it U1 chip. And you will need the software, basically iOS 14 and more, because you need this nearby interaction SDK. Okay. In Android, it's a different case. Even some of the devices that actually support UWB, they have a very bad antenna, which you shouldn't actually use, mostly in some Xiaomi devices. I'm not saying nothing here. I'm not dissing anyone. I'm just being honest. And yeah, you have in starting from Samsung in S21 Ultra and more, Pixel S6 Pro and more, you can actually have from Android 12 these UWB Jetpack APIs, and basically all the flagship phones that you have here there have the UWB antenna. So now the cool part, multi-radio thing. We have to differentiate a little bit between UWB, BLE, Wi-Fi, and when to use when. Whenever I'm talking about Wi-Fi, I'm not talking about Wi-Fi in general. It's Wi-Fi direct or Wi-Fi P2P. And you have to understand when to use each of these radio technologies. That's like the beginning, because somehow they answer to different questions. Let's say, and let's summarize it, this is something that I invented, it's not like theoretically, is UWB answers where. Where is the device that you are connecting to? What is the direction of the device? UWB is amazing for anything related to distance, where is the device, location tracking, and things like that. That's how UWB shines. Then the BLE answers a little bit the when actually we should then send the data. Is it periodically, like every 100 milliseconds? And you actually send the data there. Specifically because in BLE, you can send much of data, and it doesn't consume that much of the battery. And this is the problem in Wi-Fi, for example, Wi-Fi Direct, or the problem in UWB. Since in UWB we send this much pulses, it is actually needed, you will actually run out of battery. So most of the cases when you want to send triggers or action or things like that, and we are going to see the example of my BMW and how we do it on that, and actually also there is a live demo there. We use BLE for sending commands, for sending things like that, and this is why it's like the most used technology out there, no? So again, it answers the when question, when should we do that? And the Wi-Fi then answers the what, is basically which content do you want to send. So if we want to say it in a way, UWB is very good for health devices. Actually, it's very used in the health industry. For health devices, for precise location, for air tags, for example, which actually use UWB. For anything related to AR, augmented reality, things like that. BLE is more for, okay, I need to send a lot of data for a health tracker, something like this. In our case, also to cars, that you want to connect to cars, things like that. It's much better to have this low power and short range. Also, it's important that Bluetooth is good, but it's short range compared to Wi-Fi. So whenever you need something like very long range, you would need something like Wi-Fi. And Wi-Fi, it's more for streaming data whenever you want to send really heavy data. No? Well, for example, in the case of AirDrop or in the case of other technologies, whenever you want to send a file or something like this, it will have, and we will see it on the example more, it will have to connect and find the devices using BLE because you don't want to spend that much energy trying to find the devices. But then whenever you need to actually send the data, you will use the Wi-Fi. Cool. So again, now let's understand how these technologies work together. So first of all, this is in every multi-radio app somehow. You will have these steps that actually is repeated. And now with the focus also adding UWB in mind, okay? So first of all, you will need to actually discover the devices. Who's nearby? You need to ask, yeah, okay, who wants to connect with me? Then you will find the devices. This is normally done, like I mentioned, normally done on BLE in Bluetooth Low Energy. And then there are some technologies that actually use also Wi-Fi. For example, on Apple, there's a technology of nearby. You can get to see who is actually nearby based on that. But the normal thing is using BLE in these cases. Because these radios are low powered and good for initial handshake, because we need to do this initial handshake. We will see the example next. So there are cases, there are cases specifically like, for example, in AirDrop that recently after, I think iOS 11, when it was introduced recently the U1, they started to even use UWB. So for example, if you see the list or the airdrop, when you find the devices, you will find the devices with BLE, but then they will prioritize the list based on UWB because you can get much precise data. And you will see also that sometimes there is a contact that goes up that basically is the closer contact to you. And also there are some more features, like for example, pointing to the device and then sending the airdrop. This is also using UWB. Of course, the second step and the most important step, where normally it fails more, is basically creating this secure channel establishment, basically. The channel where we are gonna connect. So once the devices are discovered, they need a secure channel to exchange the keys, the tokens that we will have, so we can communicate securely. And normally, again, this also happens on BLE. Now you've seen a pattern, no? That normally BLE is quite useful for a lot of cases, and it's mostly used in everything. This can happen over BLE, Wi-Fi Direct, like for example, again, Google Nearby Connection uses this Bluetooth plus Wi-Fi. Multi-peer connectivity also in iOS uses this Bluetooth plus Wi-Fi. It keeps changing between the, and this is why this talk is important. It keeps changing about which antenna should you use, which radio should you use based on the case scenario that they are doing. Then after we have this channel establishment, we will need this out of band, OOB. Normally, this is how it's presented in documentation and things like that. OOB, that is basically out of band. And this is specifically for UWB. Now we are talking only about UWB. UWB, to be able to connect to another device and start ranging, it will need you, after you have already a connection and Bluetooth, it will need you to give some exchange of the token. Normally this token is called discovery token, that basically allows you and tells the other device, yeah, I'm happy to actually range with you and give you my location 24/7. Of course, this is some sensitive data. This is why sometimes they ask like, okay, but why not using UWB for everything? Why not using UWB for discovering? Why not using the UWB for even like sending data, and then we don't have to depend on BLE? That's not possible. The idea that you have already get the channel and then exchange the tokens on that. And again, the UWB is quite suitable and it's very nice for precision location, things like that, not actually for exchanging tokens or big data, anything like that. It's not suitable for that. You will actually run out of battery if you want to try to do discovery with UWB. It's not possible. And this ensures basically that only the authenticated peers, whoever you give the token to, can send the ranging. Then we can start something that we call the UW ranging session. And this ranging session basically is sending this information that is being sent every 2 milliseconds, something like this. 200 milliseconds, sorry. Then you will get this centimeter level accuracy, and you will get something called azimuth and elevation. We will see it on values. That is basically what powers all of this technology. Azimuth is more like a horizontal angle, and elevation is basically in the vertical angle of the device. So azimuth will give you the coordinates, or will give you the values, that how far is it from you, the other device that you are connected to, that you are doing the ranging horizontally, and elevation will give you more like the angle vertically, where is it. So this is why you can get actually like a good angle. And if you see it on real cases, like for example, find my device, you will see, yeah, it's down or it's up, it's down or it's up. So it's based on this information. Now let's talk Flutter, since we are on Fluttercon. No? There are some plugins for Wi-Fi P2B. Again, we were talking about Wi-Fi P2B. And Bluetooth Low Energy. First of all, since I'm seeing that many of you already get their mobiles, you will get later the talk, basically the recording and everything. And this is why I put the QR code, so you can actually scan it later. There is no official SDK neither on Bluetooth or neither on Wi-Fi P2P. But the community, this amazing community, and I don't know, maybe actually the creator of this package is here. The Flutter Blue Plus is quite known in the community. It's quite used. It's not official, but it's quite stable. This is the QR code for it. And Wi-Fi Direct plugin. This is more hard. Actually, it's quite a new package that I've seen. I've tested it in many demos. I wouldn't advise you to actually do it in a real app that you are going to release to the public. But yeah, you also have a plugin there. But for UWB, sorry, there is no official SDK, or even like from the community, there is nothing like a very stable UWB plugin. There is one that is SDK from Pinpoint. It's a company, and this vendor locked black box. You don't know anything. You can't test. It's just basically with the devices that they have. But there is one that is from Christian Greiner. Will be nice, actually. Is he here? Just no, of course not. No. There's a master thesis by this guy. I don't know him. I just seen him on GitHub, and he has some code based on the Qorvo that is basically providing antennas. It's a company that provides antennas for many other companies. Like for example, I think some of the Chinese mobiles actually use this Qorvo technology, and also you can buy it in Amazon. You can buy some UWB device, so for wherever you want to do some tests. I have it in home, and it's quite useful. But in this case, with this code, the issue here, and this one, the QR code is basically about this guy, Christian Greiner. The issue here is that it's not using a way of connecting just based on BLE. It uses the SDKs provided by Google and the SDK provided by Apple. The Google nearby connection is quite cool, and then you can find really a device to pair with very quick. But the difficulty here, or the thing that limits you, is actually that you will need to scan only for Android devices. So why I'm talking about that? So if you have an Android device, you will not be able to connect with an iOS device. There's no cross platforms. So only Google nearby connection will be connecting to Android devices, and Apple multi-peer connectivity will connect with Apple devices. So no ability to actually connect between iOS and Android on cross-platform. But good news, and this is why I'm here. I've been creating, like this last maybe 3 months, I've been creating a plugin for it. It's not yet finished. And the idea is that this plugin will be cross-platform out of the box. Basically, we are going to do this BLE gut spot, so basically discovery and all the handshake process will be done in BLE, and this allows me actually to be able to do it in every technology. You won't need to do this exchange on just SDKs from Google or SDKs from Apple. And this is actually even better. Because they changed so much the SDKs, and in our case on Flutter, whoever actually maintained a plugin before knows that the issue is that normally the native SDKs changed a lot, and you will have to adapt them, and you don't have time for it. And buy me a coffee is not enough sometimes for having all of this time spent. So I'm doing a plugin for it, which I think I can publish somehow maybe next month. I won't promise anything, but you will hear some news. Actually, in the live demo, I'm using also that plugin. That is based on the just to give credit, is based also on the Christian Greener package. It's like a fork of it, but with some changes. So hopefully, I'm not the next Mark Zuckerberg. I'm gonna try to do some live demo about an app that I created for this talk. Let's see how it goes. We've seen that even like just showing the slides was a challenge. Again, for everyone, please don't do your slides with Canvas. It's stupid. I tried to do it to make it beautiful, but not useful at all. You can here see that we discovered this device. I have here another iPhone. I'm not gonna try to show it because if not, maybe it disconnects. Again, you will need iPhone 11 above, anything that has UWB antenna. And in this case, I have iPhone 12 and iPhone 16. And you can see actually that even in different version, the antenna changes that much that you will see the values and how it sends values. So idea that's that we are gonna do the process that I mentioned in the 1, 2, 3, 4 steps. Basically, this is the discovery, and here is done with Bluetooth. It discovers the devices. Here it discovers my device. I connect to this device. Then I will see a request from here. And hopefully, it starts ranging. I'm not gonna move that much, but if you see here, already we are receiving some very precise values based on centimeters also. And you also can see that here, actually, there's also some normalization of values here, so we don't get crazy and the app doesn't break. Since, I've done it all in the same isolate. Actually, one of the things that I'm going to talk about, don't do it in the same isolate, but I did it for the example, so yeah. And if you see here, you're going to see some values. The elevation, basically, again, means that how it changed, like how far is it in a vertical sense, and the azimuth is basically horizontal. And you can see that you can, this is cool. Please do it again. Please do it again. Yeah. You can see that sometimes it goes to 0. Suddenly it goes to 0. This is a way for, okay, I'm not confident about my values. I'm not gonna give you anything. And sometimes you need to move actually to have some values again. But the application is not only in cars or in technologies like that. Sometimes you can do something stupid like this. You can do a funny game that basically is a sword. You don't hear the noise. I spend all the night trying to find a sound that actually is like Star Wars. So if you're a fan of Star Wars, you will use UWB to basically fight. I was playing with it in home with my brother, and it was fun actually. Like, so this is the demo, and this is how actually UW powers many applications and this beautiful game. Now, let's try to go back to the slides, if this is possible. I think we were on this slide. I disconnect this because actually it spends all the battery. And it's all the time because also, funny stuff. I wanted to also do some vibration, and for some reason I thought that you can see it. Just forget about it. Like, but this is not what you need to see. Again, don't do it on Canva. Can you imagine that there is here some Canva developer or something, and then they will be mad at what I'm saying? Okay, we've seen the live demo so far, and let's start with the case study, and now live experiences with this UWB technology and this multi-radio thing. So the first case study, I mean, the only case study that we're going to do is basically what we had on BMW. Again, thanks for allowing me to talk about all of this. There was a challenge, and there is a specific case that I'm going to talk more about. It is basically RCP. RCP stands for remote control parking. The challenge that we had was that we want to enable the driver to remotely park or maneuver the car from outside, only using the smartphone. Quite a big challenge, no? Because there's security things, security issues, there's a lot of requirements. We needed like also secure authentication. We needed also a secure, how we call it? Secure location, yeah, somehow, yeah, that you actually have some range. There is something called RKE range that we have on BMW, that basically is the range that you are allowed to start a RCP session. RCP again stands for remote control parking. So now I'm gonna just say RCP, and this RCP session can be only done on this range that basically 6 meters right now. Okay. So let's first see then a video that you are not seeing for some reason. Yeah, now you're seeing it. Again, this is not a spam. They didn't pay me for this. But if you see, this is the app, my BMW app. And you can see here some parking spots, which you are allowed to start parking in. And in this case, you will need to do some calibration. This is some secure mechanism to ensure that actually you want to do this parking, and it's not basically your mobile and in your pocket and just click it. And then with just a trigger, that in this case, this is called automated not recorded path, that basically has a part already recorded from the car, and then you just click to it, and yeah, like you see, then it parks. Cool stuff. But in the background, many things is happening. There is also other things, like for example, you can actually manually like drive your car forward and backward. Again, you need to do this calibration screen. Let's see if these guys do it. Do it. Do it, yeah, this one. Basically, you can do also some manual maneuvers wherever you want, for example, just to, your car is already parked. So yeah, normally they understand remote control parking is only about parking, but sometimes you want to actually get your car out, and basically it's in a very tight position, and then you connect with your mobile and then just do forwards, and you can go to your car. Very useful cases. So there is a convention that was created, is the CCC. And then they defined how is the multi-radio that is going to be working for all the cars manufacturers, not for only for BMW. And also this was useful for companies like Apple or Google to actually create this SDKs that we need from the device. No? So the protocol right now is basically BLE, Bluetooth Low Energy, is used for everything regarding communication channels. Any commands that you will see, we're going to talk about more about it later, is done on BLE. All of this that you see is done on the same technology that you connect your AirPods to. So yeah, pretty cool stuff. And UWB basically is used for secure ranging, spatial awareness, basically to see. We have also some cases that, yeah, we don't want you to be allowed or to actually try to do a remote control parking session if you are inside your car. So for example, UW is also useful for that, to actually know if you are inside your car. And for example, again, like we mentioned, the RK range. You are on the RK range or not in this 6 meter that you are allowed to do it or not. Yeah. And basically now we are going to talk more only about the Apple SDK for the car key API SDK. Why I'm only talking about Apple? Google, for some reason, we normally say always that, yeah, Apple is the one that doesn't talk about their technology, things like that. In this case, at least, Apple released the SDK, or released the API documentation. Actually, everyone can actually see it, the car key API, but Google not. So I only can talk about this one. So this defines how we actually send the actions, how we actually send the triggers. And in the case of RCP, only in RCP, because we also have many other technologies, like for example in RKE, we have some of our amazing developers that are doing RKE here present. that uses another method, and it's more about a trigger. So basically, there is an RKey action that you can send, and then this trigger the car already knows that this trigger means, okay, open the door. The car knows already that trigger is basically, close the windows, bunch of stuff. But in the case of RCP, we want to send bytes, and this was the biggest challenge because we actually exchange with the car zeros and ones. And then there is a Bluetooth protocol that it's widely known between the car team and us, and we agree on that. Like, yeah, this 0 here means, do that. This 1 here means, do that. Okay. So this is why we needed something provided from a company like Apple. In this case, we're using the digital key to actually provide us a method that allow us to send all of this information. And this is basically the same pass-through data. Oh, I'm running out of time. So lessons learned. And this is maybe the most useful part of the talk. Basically, the power and reliability, it's quite important. And UWB consumes more than they say. For some reason, even like doing only this demo, I can just get 20%. I was 100% of my battery, and then 20% in just 2 hours. So it consumes a lot. So you need to optimize it a lot. You need to check the battery from time to time, how actually is spending the battery UWB. And in most of the cases, actually, we're going to also see it, a UWB session is very short. It's only 3 minutes. Normally from 2 to 3 minutes. There is no official documentation about that, but based on test, I can tell you it's basically from 2 to 3 minutes. And then you can renew it, but normally the sessions are from 2 to 3 minutes. Makes sense, so you don't drain the battery like I'm doing, playing some sports. But even if we are not talking about UWB, if we are talking also about BLE, because now we are talking in general, you have to really check what is your messages that you are sending every time. You have to optimize it. If you can do other things, like we are going to talk about it in architecture, try to save as much energy as possible. And fallback is needed. Sometimes, then if you are missing UWB because, the session got killed or something like this, then you need to use BLE. Don't just fail to the user, because if you are only based on UWB in many cases, like I mentioned, in Android phones or things like that, you will fail most of the time. So you will have to do some fallback in this case. Also, some platform and OS consideration and restriction. Basically, in iOS, the background BLE and UWB scanning is very limited, very, very limited. There are some special entitlements that actually big companies can ask for it. BMW, for example, does it, where you are more allowed to do things in the background. But for us as indie developers or anyone that's working on normal companies, you can't do that much heavily processes on iOS. On Android, it was possible until some version, but starting from recent Android versions, they also limited the UWB to require foreground activity. You now are required to do foreground activity, not do it on the background, unless again the app have some special allowance. And like I mentioned many times, I'm going to mention it again. There is a lot of very bad UWB antennas that send stupid data. So try to fix it at least with some data normalization. And security and sessions, encrypt as much as possible. Don't rely too much on what's already done. If you have some sensitive data, for example, user data that's being sent on BLE commands or anything, for example, in our case on BMW, if you are sending that much critical information, of course, don't send it without encrypting, okay? Then you will actually regret if you don't do it. And again, the UWB sessions are really short-lived. Normally it's like 3 minutes. Multi-device and user experience, basically, there are cases like in cars and on some other technologies like IoT devices that allow you to have multiple sessions. In this case, in car, we'll talk more about digital keys than sessions because basically it's what triggers everything. So you will have to know already from business logic which device you are going to choose and how are you going to change between the devices based on priority that you want to give, distance or anything like that. Now we are going to go to the interesting stuff, architecture. You should devounce and throttle state updates as much as possible. Because, again, for example, in UWB, you receive a lot of pulse signals, and it's very quick, so you will need some of this data to be skipped. The bounce is basically mentioning, okay, I only want to have every 200 milliseconds something, okay? Same for throttle. And of course, like any other app, I will tell you the same. Use select source notifier based on blocks, whatever you want, which any state that you want. Separation of concerns helps, and this is really important. Try to keep the ranging in a package, the discovery in a separated package, and not everything on the same package. Because if you need to change something just because the SDK updated, you will break it. So data smoothing is very important. Like I mentioned, some of these values changes a lot and provide you like a bad user experience. This is what actually I wanted to also show you the swords, how was like the sword moving a lot. This based on acceleration, it's not based on UWB, based on the accelerometer of the device itself. But you can see how bad it moved, no? The idea is if you normalize these values, you will see a much better user experience. Of course, some sync loops are needed to basically ensure that the session, UW session, for example, in this case, that is every 3 minutes, can be still done, you can still be doing it. And still updates are actually more common than you think. Like we've seen it, and it was milliseconds, but yeah, sometimes then suddenly you get bad data, null data, data that's already outdated, and you are here, and then it still says that you are there. So it's quite common, even in very good technologies like UWP. So you will have to take care about it. Multi-threading, don't do as I did here on this example app. Most of the devices that we currently have, the mobiles, actually can allow you to do multi-threading. Why not doing it? Don't do everything on the same thread. Use some isolates. And the MTU side, MTU stands for maximum transmission unit, I think. Yeah, maximum transmission unit. By default, is very low. By default, it's only 32 bytes, I think, that actually for the usable app itself is only 20 bytes that you can send information. I'm talking about BLE now. In this case, 20 bytes, whenever you are sending to the car information, very valuable information, is not enough. So you can do some negotiation. Actually, there's methods that allows you. Most of you probably have heard about it or used it. All the modern stacks allow you to actually negotiate to have a better MTU. And this is useful because then you will have to send, or you can send less messages and messages more packed with more information. So if you can do it, that's good. But don't depend on it because some devices don't allow you, for example, to have better MTU, so you'll have to go to the default MTU. Yes, sorry. 6, optimize, and keep optimizing. It's very important to optimize. Use type data actually whenever possible. Whenever you can use type data, use it. If it's not useful to use objects, don't do it. And for example, in our case, in remote control party, we were using, again, like we mentioned, bytes. Since type data doesn't have the same space, there are some pointers and some things that is being done in the strong type data, so you don't need it there, especially for this kind of messages when you have actually a protocol agreed between the device and the other device. Don't do periodically messages. Normally we tend to have hundreds of timers. We actually have a big documentation. I don't know where is it here. We have a big documentation just about the timers, and yeah, don't do it too much because you will find it. Try to be more event triggered. If for example, this happened, then do this. If this message is being sent, then do this. It's easy to do timers, but don't do it that much. And of course, track the message volume. This is really important. And especially battery optimization, like I mentioned, but also how much data you are sending, because if not, you are going to see how bad Bluetooth connection you are going to have. It's very useful also to have some there was a colleague that did a Jupyter notebook where actually with a visual way, the whole messages that we are sending on the app based on the logs that we have. This is why actually it's useful to have logs. And then with all of these messages, we've seen that, yeah, we've sent them too much information. And I think that I'm actually running out of time. So thank you so much. This is the end, but there is also some time to have some Q&A. This is the link where you can actually connect with me, LinkedIn, Twitter, anything. Hopefully you enjoyed the talk, and thank you very much.